Okay, this is another paper, paper 5, February, March 2021, and the variant is 5.2. So we have to attempt question number 2 now. Okay, question is, the student investigate the collision of the two gliders A and B on the linear air track. The light gate is connected to the timer. A card of length L is attached to the glider B. The mass of the glider B and the card is M. The glider B is initially at rest. The student releases the glider A so that it travels at the constant velocity u towards the stationary glider B, and the gliders collide and then separate. The card on the glider B passes through the light gate. The student records the time small t for the card to pass through the light gate from the timer. The student changes the mass of the glider B and repeats the experiment. It is suggested that the velocity v of the glider B as it passes through the light gate and m are related by the equation v is equal to 2ua over m plus a, where a is the mass of the glider, m is also mass, u is the velocity, and this is the velocity of the glider A, and v is the final velocity of the glider B, which is required. The question is, the graph is plotted 1 over v on the y-axis against the m on the x-axis. Determine the expression for the gradient. Look, 1 over e required. So we will write this equation: 1 over v is equal to m plus a divided by 2ua. Mean 1 over v is equal to m divided by 2ua plus a divided by 2ua. So this 2ua is divided separately on both m and a. Now this a is cancelled. Now the equation is 1 over v is equal to m divided by 2ua plus 1 over 2u, which can be written as 1 over v 1 over 2ua times mass m plus 1 over 2u when it is compared with a linear equation mx plus c. So m required at the x-axis, 1 over v at the y-axis. So this 1 over 2ua is the gradient, and this term 1 over 2u is the y-intercept. Now the next part is, the values of m and t are given in the table. Calculate the required value of 1 over v. Look, 1 over v is given here, t over L. So 1 over v is equal to t divided by L. So the first, this t is 0.23 divided by length is given 5. So 0.23 divided by 5. So this is the answer, 0.046. Similarly, we can calculate next 0.26 time divided by length 5. So this is the answer. Then 0.31 divided by 5. This is the answer. 0.36 divided by 5. This one. 0.40 this. 0.44 this one. Now the important point is we have to calculate the absolute uncertainty. 1 over v. So delta 1 over v is equal to 1 over v maximum value minus 1 over v the calculated value. In maximum minus the normal value. So look, 1 over v is equal to t divided by L. This 1 over v maximum value can be calculated by using the maximum value of the time, but the minimum value of the length. So look, the maximum time first is 0.23 plus 0.01, mean it is 0.24. This is the maximum value of the time. And the minimum value of the length will be 5 minus 0.1. It is 4.9. This value after calculation is coming 0.04899, so approximately 0.049. So this is the maximum value. Now we have to calculate delta 1 over v. So first we have to write the maximum value, 0.049 minus the normal value, which is calculated here, 0.046. So 0.046. So the answer is coming 0.003. So here we have to write the error, 0.003. There is another method for 1 over v. and that is 1 over V percent uncertainty is equal to percentage of T plus percentage of L. So first calculate the percentage of T. So it will be 0.01 divided by 0.23 multiplied by 100 plus the length percentage 0.1 divided by 5 into 100. So this answer, this is approximately 4.35%, and plus this percentage will be 100 multiplied by 10 divided by 5 2. So it is 6.35%. Now we have to calculate the 6.35% of this value, 0.046. So 6.35 divided by 100 multiplied by 0.046. So 6.35 divided by 100 multiply by 0.046. The answer is coming approximately 0.0029. So same answer, 0.003. So either use this method or this, it's up to you. Now, second, same method. This one, maximum value minus the minimum value. Now the maximum value for this will be, for the 1 over V max will be, the maximum value of the T will be 0.27 divided by the minimum value, 5 minus 1, 4.7. So it is 0.27 divided by 4.9 and minus this value, maximum value minus the normal value. This value is 0.052. So minus 0.052. The answer is coming again same, 0.003. So this is the method to calculate the uncertainty, either by using this maximum minus minimum, maximum minus the normal value, or the percentage uncertainty is up to you. Okay, after the calculation, the next answer of the uncertainty is also coming 0.003, and the next is coming 0.004. Next is also 0.4. Last is also 0.004. So this is the table for 2 marks. Now the next question is, plot the graph 1 over V on the against M in gram, include the error bars. So we have to plot the graph here. Y-axis, x-axis, both are labeled. So we have to plot the graph. Okay, in the table, the first point is M is 271. So this is 200, 210, 20, 30, 40, 50, 60, 70 approximately here at the x-axis. And the y-axis, this is 0.046. 0.046. So this is 0.05. This will be 0.06. This will be 7, 8, 9, and 10. Yes, so this is 0.06. This is the first point. Now the next point is 369. So approximately 370. So 310, 20, 30, 40, 50, 60, and 70. So this value here. And at the y-axis, this is 0.052. 0.052. So this is 0.0. This is 51. This is approximately the point. And the next mass is 490. So this is 490, and y-axis 0.062. So 0.062. This is the point. And the next is 632. So this is 610, this is 20, this is 30, and this will be 632. And the y-axis is 0.072. 0.072. This is 71, this is 72. And the next is 741. So 7, 10, 20, 30, 40, and the 41. And we have to draw the point at 0.080. So 1, 2, 3, 4. This is the point. And the next point is 840. So this is the point, which is the 840. And at the y-axis, this is 0.088. 0.088. So this is 0.86. This is 7, and this is 8. So these are the points. Okay, now we have to draw the error bars, and the errors are in the quantity 1 over y, which is plotted at the y-axis. So first we have to calculate the error scale constant for the y-axis. So the 5 y-axis, we have to draw vertical bars. So error scale constant, number of the small boxes divided by difference of the reading. You can take any number. For example, I take these 10 boxes, and their difference of the reading will be, it is 0.005. Now the 10 divided by 0.005, it is 2000. So error scale constant is 2000. Now the method is multiply errors with the error scale constant. Look, the first, second, and third is 0.003. So when multiplied by 2000, this becomes 6, this becomes 6, this is 6, this is 8, 8, 8. Mean error multiplied by error scale constant. So the answer coming 6, 6, 6. So it means the height of the first error up and down from the point will be 6 boxes, 6 boxes, 6, then 8, 8, and 8 boxes. So we draw the error bars, 6 boxes up and 6 boxes down. So 1, 2, 3, 4, 5, and 6. So this is the bar, this side. Similarly, 1, 2, 3, 4, 5, and 6. So this is the bar. So block the bar, block the line. So this is the error bar, first point. Now similarly, 6 for the next. So 1, 2, 3, 4, 5, and 6 up and 6 down. 1, 2, 3, 4, 5, and 6. Third is also 6. So it is 1, 2, 3, 4, 5, and 6. And then 1, 2, 3, 4, 5, and 6. And the next 3 are 8. So 2, 4, 6, and 8. And similarly here, 2, 4, 6, and 8. Use a scale for these bars. So 1, 2, 3, and 4. So 8 boxes here. So 1, 2, 3, and 4. 8 boxes down. And similarly here, 1, 2, 3, and 4. 8 boxes up. 1, 2, 3, and 4. 8 boxes down. So these are the error bars. So the method is error scale constant multiply by error. That is the height, that's the length, one side of the point for the error bar. Now we have to draw the best fit line and the worst acceptable line. So this red line is the best fit line, almost touching all points, passing through all points, but you can draw better line on the actual graph paper. Okay, now we have to label it. This is your best fit line. Now we have to draw the worst acceptable line. For the worst acceptable line, we will select this last bar and the first bar. So we have to join them if the top of the last is selected, then the bottom of the first is joined with the top of the last. This blue line, which is joining the bottom of the first bar and the top of the last bar, this is the worst acceptable line. So we have to label both lines. Now, the next point is we have to calculate the gradient and with uncertainty. So we have to calculate both gradient of the best fit and gradient of the worst fit. Now select points, 2 different points for each line. For example, the best fit points are labeled P1 and P2, and worst acceptable line, they are labeled P3 and P4. Okay, 2 points are selected for the best fit. First point is this P1 and its coordinate. X coordinate is 300 and the Y is 0.475. So we will write here 300 and 0.0475. So this is, yes, not 0.0. So this is 0.0475. And the next point is P2. It is 810 at the x-axis, 810 at the x-axis and 0.085 at the y-axis. So 810 and 0.085. So we calculate the gradient for these two. So the gradient is equal to y2 minus y1 over x2 minus x1. So 0.085 minus 0.0475 divided by 810 minus 300. Okay, after the calculation, this value is coming 0.0375 divided by this 510. So the best fit gradient is 7.35 into 10 power minus 5. Now move to worst acceptable line. Select any 2 points. For example, we take this point. This is supposed to be 3. Its coordinate is 420 and the y-axis 0.055. So this P3 is 420, 0.055. And another point, suppose we take this point. This one, this is P4 and its coordinates. This is 700, 10, 20, 30, 40, 50, and 60. So 760. And at the y-axis, 0.085, 0.085. This is P4. So 760 and 0.085. Now calculate the gradient of this worst acceptable line. So 0.085 minus 0.055 divided by 760 minus 420. Okay, after the calculation, this gradient of the worst acceptable line is coming 0.030 divided by 340, 8.85 into 10 power minus 5. Now, we have to write the answer for the gradient. So first, the gradient of the best fit, which is 7.35 into 10 power minus 5, and plus minus the difference of these two values. So look, 8.82 minus 7.35, it is 1.47 into 10 power minus 5. Okay, final answer of the gradient will be 7.4 plus minus 1.5 into 10 power minus 5. So this is the final answer. You can write also 7.4 plus minus this 1.5. You can write 2 into 10 power minus 5. So both correct. Now move to the next. Okay, In the next part, determine the y-intercept of the line of the best fit, include the absolute uncertainty. So we have to calculate the y-intercept for both lines. So y is equal to mx plus c. So c is equal to y minus mx. So this is for the best fit. So we will put here the coordinate of the best fit. Suppose the coordinate of the best fit P1 or P2. So P1 is 300.045. So its y coordinate is 0.0475 minus the gradient of the best fit is 7.35 into 10 power minus 5 and multiply by x coordinate, which is 300. So after the calculation, it is coming approximately 0.025. Now, similarly for the worst acceptable line, so C is equal to y minus mx. C is equal to the y coordinate of any point of the worst fit. For example, we take 0.085, this is P4, minus the gradient of the worst fit, and the gradient of the worst fit is 8.85 into 10 power minus 5, and P4x coordinate is 760. So after calculation, the worst acceptable line y-intercept is coming 0.018, and this is the y-intercept of the best fit line 0.025. So the actual value of the y-intercept will be 0.025 plus minus the difference of these two, and it is coming 0.007, and this is the answer for the y-intercept. No need to write the units because units not required, not asked in the question. Next is using the answer to A, C3 and C2, determine the value of U and A, include appropriate unit. So look at the gradient and the y-intercept. Look, the y-intercept is equal to 1 over U. So we can write U is equal to 1 divided by 2 times y-intercept. So 1 divided by 2 times 0.025, and after the calculation, the answer will be, so the answer is 20. So it is 20, and the gradient is equal to 1 divided by 2UA. So A is required. It means 1 divided by 2U times gradient. So 1 divided by 2 into 20 into the gradient. And the gradient is coming 7.35 for the best fit into 10 power minus 5 after the calculation. Okay, after calculation, this is coming 340. Now the question is, include appropriate unit. So this is the speed test. It's mentioned in the statement. So this is a centimeter per second, and this is the mass in gram. So the U is 20 centimeter per second, and A is 340 gram. For two significant figure, you can write it 2.0 into 10 power 1 centimeter per second. It's up to you. So there's 340 gram. Now the question is, determine the percentage uncertainty in A. Look, A is calculated from 1 over 2 UM. U is calculated from the y-intercept, and the U is 1 over 2 times C. It means y-intercept and the gradient are used, so the percentage uncertainty of A is the percentage of C plus percentage of gradient M, because A is equal to 1 divided by 2 times U, and U is 1 divided by 2C. Look, from this equation, multiply by this gradient. Now 2 cancelled, so A is equal to C divided by M. So the percentage uncertainty of C, y-intercept, plus percentage uncertainty of M is the percentage of A. So we will write the percentage uncertainty of C, which is 0.007 divided by 0.025 into 100, and plus the percentage uncertainty of the gradient. Okay, so the percentage uncertainty of the gradient will be 1.5 into 10 power, 1.47 in 10 power minus 5 divided by 7.35 into 10 power minus 5 into 100. This is cancelled. So after calculation, the answer will be, okay, so this calculation is coming 28 and this is coming 20.4. So the total, it becomes 48.4. So we will write here 48%. Your answer will be different because you can calculate the best answer for the gradient by drawing the best line for the best fit and for the worst fit. Okay, so this is just the method of the calculation. Okay, the next is the experiment is repeated. Determine the mass M of the glider B and the card T when T has value of 0.5. Okay, look, the actual equation is 1 over V is equal to M plus A divided by 2UA. Now this 1 over V can be written as T divided by L is equal to M plus A divided by 2UA. Now M is required. So this T is equal to 0.5 and the length is given 5 centimeter. The mass M is required plus A calculated is 340 divided by this 2 and the U is 20. Yes, and the A is calculated 340. So after calculation, the answer of the M will be, okay, after calculation, look, this is multiplied over here. So 0.5 divided by 5.1 multiplied by this, M plus 340. So 1360 minus 340, this is coming 1020 gram. This is the mass. Okay, after calculating gradient from these points, you have to join for the working of the gradient P1 and P2 with triangle, dotted triangle, yes, like this. This is your P1. And similarly, you have to join P3 and P4 with a dotted triangle. Use a scale for this line, okay? So this is important for the working of the gradient.